Good afternoon, students. So in the last class we have discussed the combinational circuits, right? So a small little part of module 2 is remaining. So that theoretical part, that is PLD, FPGA, right, or the logic programmable logic devices, these are all will be covered by Bagli sir later in the subject. Okay, so in today's class we will start with the third module, which is sequential circuits, right? So as I already discussed, what is a combination circuit and what is a sequential circuit, let me revise it again. Okay, so combination circuit, or the circuits till we discussed today, those were in module 1 and module 2, those were combination circuit in which the output depends on, or the output of those circuits depend on only the present inputs, right, the inputs at the present time, right? But in sequential circuits, the circuits, this is the definition of sequential circuit: the circuits in which the output depends on the present inputs and the past outputs, and the past or the previous, you can say previous outputs or output, right? So what do you mean by this, right? If I say, let me connect two AND gates. This is just an example. Okay, so if I have A here, and if I have B here, if I have C, and this is 4, these are the two input AND gates, right? And this is one output, let us say Y, and this output is Z. Okay, so here if I connect this and if I rig up this circuit, this is called a combination circuit in which the output Y depends on the present values of A and B. When A and B changes, then Y also change, right? Similarly, Z depends on the present values of C and D. Whenever C and D changes, Z also changes, right? But this is a combination circuit in which the output depends on only the present input, right? So now how can I make it to depend, how can I make these outputs to depend on the present input as well as the past output? What I'll do, I'll connect this B to Z, okay, and I'll connect this C to Y, right? So what we call this portion is, this part is called a feedback, right? A small portion of the output or the entire portion of the output is connected to input, or it is fed back to the input, right? So here the value of Z is fed back to this first AND gate. Similarly, the value of Y is fed back to this second AND gate, right? So what is the advantage of this feedback, right? So in a combination circuit, we cannot store anything. Once the power goes off, what happens? The present value or whatever output is there, that will be vanished, right? But in case of sequential circuit which have a feedback, due to this feedback, what happens? Whatever we store in the circuit, right? Whatever we store in the circuit, let us say either 0 or 1, right? So these values will be retained even the power goes off. That means the sequential circuits will act as the memory elements, right? So that memory elements, what is the reason behind that? How they act as a memory elements? That is, that memory element, they will act as a memory element because of this feedback, right? But in case of combination circuits, we don't have any feedback. So once the power goes off, the state of those circuits will be equal to 0, you can say, right? But or what you can say, the state of those combination circuits will not be retained by those circuits. But in case of sequential circuits, because of this feedback, they will act as a memory element, and even the power goes off, the state of those particular circuits will be retained as it is. Okay, so this is the basics of sequential circuit and the definition of a sequential circuit. Next we will see, we have already seen the combinational and sequential circuit difference, right? Combination circuit in which the output depends on only present input, and sequential circuit output depends on both present input and past output, right? and combination circuit, they do not have any feedback. Sequential circuits have feedback. So due to this feedback, sequential circuit act as a memory element, and we cannot use any combination circuit as a memory element. Okay, and the examples you can give, the examples still we discussed, that is decoder, encoder, mux, demux, all these fall under a combination circuit. A sequential circuits, flip-flops, latches, registers, counters, these are all come under sequential circuits. Okay, next there are two types of sequential circuits. There are two types of sequential circuits. One is a synchronous sequential circuit. Sequential circuits. There are two types of sequential circuits. One is synchronous sequential circuits, and the second one is asynchronous sequential circuits. Okay, later we'll come to know what are the different examples for these circuits. First, let me define these sequential circuits, synchronous sequential circuits. These are the circuits in which the output changes, or the output of the circuit is controlled by a certain control input, you can say control input, right? So this control input, it is like in the form of an enable. It will act as an enable, right? So as we discussed in decoder and multiplexer, until and unless we enable that particular IC, we cannot use them as either decoder or multiplexer, right? So the enable will act as a control input, right? So but in case of sequential circuit, we do not call it as a enable, we call it as a clock, right? So clock is a input signal which acts as a control input, right? So until and unless the clock changes, the output will not change. Even though the inputs are changing, the output will not be highlighted, or output will not be changed until the clock is changed, right? So such sequential circuits are called synchronous sequential circuits. Second kind is asynchronous sequential circuit, in which the output doesn't depend on the state or the value of the control signal or control input, right? So here the output doesn't depend on this control input. As soon as the input changes, the output will change. Okay, so those are the asynchronous sequential circuit, right? So the examples for asynchronous sequential circuits are latches. Later we will come to know what is a latch. And in synchronous sequential circuits, the examples are flip-flops, right? Flip-flops, registers, counters, these are all fall under synchronous sequential circuits, right? So even you will find the counters which are built, you either using synchronous sequential circuits or asynchronous sequential circuit. But asynchronous sequential circuit, they more often they act as a combination circuit, in which the output directly depends on the input. As soon as the input changes, the output changes. But in case of synchronous sequential circuits, the output depends on both, that is input as well as the control input, right? So once the input changes, the output will not be highlighted until the control signal changes. Okay. So next we will discuss, right? So I hope you understood the different types of sequential circuits. Next we will see the first asynchronous sequential circuit. So it's a simple asynchronous circuit. Okay, this is the asynchronous circuit. a synchronous circuit in which the output depends on only the present input, right? So that means the output is independent on the control input, right? And this is a basic memory element. This is a basic memory element, okay? And sometimes this is also called as a bistable element. So very soon you will come to know what are the differences between sequential or the latches and the flip-flops, okay? So first we will try to understand what is a latch, right? So latch means a lock, right? So what you are locking there, you are locking the previous value of a circuit, or the previous value which is going to be stored in that circuit, right? So the basic bistable element of any digital or a sequential circuit is called a latch, right? So let us see a simple bistable element which is made up of two NOT gates, right? So we know that a NOT gate has only single input, let us say A, and this input is B, okay? So what I'll do here, there should be a feedback. Without this feedback I cannot call it as a sequential circuit, right? So this feedback should be there, right? And we will be having two outputs, one is Q, one is Q bar, and these are called the states of the latch, right? So these are the two different states of the latch, right? Instead of calling as a output, we call them as states in a sequential circuit. In a combination circuit we call them as a normal output, okay? And these states you just see here, one is Q, one is Q bar. That means one output is, or one state is complement of another state, right? So this state is complement of this state, or this state is complement of this state, right? So Q double bar is equal to Q, right? So each state is complement of another state, right? So now how to identify this, how to work with this circuit, right? So let us say once the power goes off, let us assume the state of the latch is, let us say, 0, right? So this Q value actual value of Q will tell you what is the state of that particular latch. Q will tell the state of the latch, right? So if Q is 0, then state of the latch is 0. If Q is 1, then state of the latch is 1, right? So let us assume when the power goes off, the state of the latch is 0. Since Q is 0, Q bar will be equal to 1, right? So both are complement to each other. And one more thing you remember, in this sequential circuit, the outputs are always complement to each other, right? So if you have two outputs, let us say one is Q, then second output must be, or second state must be Q bar, right? So then only we can say both these states are complement to each other. Next, now once the power, if I apply power to this circuit, right? So what I'll do, I'll keep A is equal to 1. I'll keep A is equal to 0. So once I make A is equal to 0, what happens? The output of first NOT gate, will be equal to 1, right? So what happens in that case? Q will become 1 and Q bar will become 0. How Q bar will become 0? Because once Q becomes 1, the output of, or the value of Q is applied to the input of second. Since here we are not applying any input for this B, second input, right? So the output of first NOT gate itself acts as an input for second NOT gate, right? Since Q is high, which is applied to input of second NOT gate, right? So output of second NOT gate will be equal to 0. That means Q bar is equal to 0. Similarly, when I make A is equal to 1, and still the power is on, right? When A is made high, what happens to Q? Q is a complement of A. That means Q will become 0, right? So Q will become 0, and this value is applied to the input of second second NOT gate, right? So output of second NOT gate will become 1, right? So you can observe here, Q and Q bar are always complement to each other. So this is the working of a simple latch. As soon as the input changes, output will also change. So you can also observe that there is no control signal in this latch. Okay. So this is a basic bistable element, which we also call it as latch, right? So that is without any control signal, right? So one more kind of a bistable element, in which we call it as flip-flop. So another bistable element, which we call it as flip-flop, right? So in flip-flop, this is a bistable element, or this is an example for a synchronous sequential circuit, right? So this is an example for synchronous sequential circuit. This is also called as bistable element, right? So that was the bistable element for that is asynchronous sequential circuit, and this is also a bistable element which will also act as a memory, right? But we call it as synchronous sequential circuit, right? A synchronous sequential circuit, right? So what happens in this case? Let us assume or before this, what we will do, we will finish up the latch, then we will take the subject of flip-flop. Okay. So what we will do, we will temporarily, for time being, we will skip this flip-flop. First we will discuss all the latches. Okay. The second kind of latch is called a SR latch, right? So what is SR stands for? We will also have a SR flip-flop. S stands for set and R stands for reset, right? So we hardly use these latches, right? So the main sequential components or main sequential circuit components are the flip-flops, because there we have a control signal, right? And the outputs can be controlled with the help of those control signals. So I do not recommend to use latches. I do not recommend to use these latches for a memory element, right? So but we have to understand the concept of flip-flop, we require the concept of SR or latches, right? So let us take the SR latch, which is made up of two NOR gates. Okay, two NOR gates, and as the name itself tells, one output is a Q, second output is the Q bar. Okay, so one input is S, right? But this will be R, and there will be a feedback, right? And second input will be S. So this we call it as set, and this we call it as reset, right? So what do you mean by set, right? So when S is high, the latch is set. That means Q will be equal to 1, right? So I will explain it with the different values of S and R. We will explain this circuit. I will explain this circuit. Okay. And when reset is high, then the latch will be reset. That means Q will become 0. That means the state of the latch will become 0, right? So we will discuss this in the next slide. Okay.